Professor David Karowe from Western Michigan University. Dr. Karowe's students are investigating potential ecological consequences of elevated atmospheric carbon dioxide. Dr. Karowe's lab is looking into how the nutritional quality and defensive chemistry of plants change under elevated CO2, and how such changes affect the growth, survivorship, and behavior of insect herbivores and parasitoids. The ultimate goal of this research is to expand understanding of the ecological and evolutionary consequences of elevated CO2 to include higher trophic levels. This work has been supported by grants from the National Science Foundation and the United States Department of Agriculture. Thank you so much for coming and sharing your knowledge for us.
Thank you, Riley. Thank you for that very nice introduction and for the invitation. In case anybody heard words in Riley's description of my research that were unfamiliar or possibly carried unpleasant connotations like bugs, don't worry. We're not going to talk about my research today. We're going to talk about a broader topic, that is climate change in the Great Lakes region. So what we want to start out asking is, has climate actually been changing in our region? Climate includes pretty much anything you could think of as part of weather, averaged over a 30-year period, but the two really big ones are temperature and precipitation. So let's take a look at how temperature has been changing. We'll see, we can focus on the Great Lakes region inside that circle. This is a video, obviously, that NASA's Goddard Institute for Space Studies put together based on thermometer records from around the globe, starting in 1880 and running up through the present day. And the way to interpret this is that for the 5-year period on the bottom of the map, the average temperature for any place on Earth during that 5-year period is indicated by a color that compares the temperature during that 5-year period to the temperature during essentially the middle of last century. So these are all temperatures relative to what that place was like between 1950 and 1980. Red is warm, blue is cool. So if it's been warming, if temperature's been changing, and if it's been changing in the Great Lakes region, we'll see a shift from blues to other colors. And the years are going by pretty fast at the bottom of the map. So we're about to hit World War II. Now, when your parents were born, probably. Now, when you were born, and up through today. So this is a 30-second video that very clearly demonstrates that within the Great Lakes region, also within pretty much everywhere in the world, and especially at high northern latitudes, temperature has been changing. It's been increasing. So that's the warming part, global warming part of climate change. Now, it may have been a little hard to see that the temperature change was not perfectly smooth and linear. For Michigan, yes, we have been warming over the entire time period. But if you really look closely, there was a period of warming up until about 1945, and then a period of no change in temperature, and then a more rapid period of more rapid warming. So over the entire thermometer record, the average annual temperature for Michigan has clearly increased, but, and you may have noticed this in the video in general for the world, the rate of warming has been speeding up in our region, just like for the entire world. Since 1975, Michigan's been warming more than twice as fast as it has over the entire thermometer record. So temperature is changing, and the change is becoming faster and faster. The water in the Great Lakes has also been warming. Every place on this map that has a color is an area where the surface water has warmed significantly over just a 20-year period, 1994 to 2013. Warming's been greatest up in Lake Superior, where in this real red area, the surface temperature's been warming, has warmed over those 2 decades by about 10 degrees Fahrenheit, which is a phenomenal change for that ecosystem. So we see the lakes are warming. Not surprisingly, that leads to a loss of ice cover. And in fact, since 1973, the Great Lakes as a whole have lost about 70% of their ice cover. And that we were in a record low ice cover until this recent polar vortex this year. Okay, so that is temperature, part of climate change in the Great Lakes region. What about precipitation? Most north temperate land masses have been receiving more precipitation. And Great Lakes region, no exception. We've been getting somewhere between 5 and 15% more precipitation over the last 50 years or so. Unfortunately, a lot of that increase in precipitation has been in the form of what we call extreme precipitation events, which typically involve water coming out of the sky. It's usually a rain event, and the rain is falling so fast that it can't simply move into the soil. It can't move into the soil fast enough, so it stays on the surface, flows to a low spot, and accumulates there. We call that a flood. So we've had in our region a little more than a 40% increase in the frequency of severe precipitation events since about 1960. Not surprisingly, that's caused a lot more flooding. You guys have, I'm sure, been aware of floods in Ann Arbor, in Grand Rapids. This is Kalamazoo, that's East Lansing. The frequency and severity of floods in Michigan and in the Great Lakes region has clearly increased. Okay, so climate's been changing. Have species and ecosystems within the Great Lakes region responded at all to these documented changes that have already happened to our climate? One of the most common responses of species is changing their seasonal timing. And one of the groups of species for which we have long-term records and therefore can detect a change in timing is the arrival of migratory birds in the spring. And it turns out that on average, migratory birds in our part of the world, in the Great Plains, anyway, are arriving about 4.5 days earlier than they used to. So this is their first arrival date documented between 1910 and 1940. This is the same thing, but 2000 to 2012. If they were arriving at exactly the same date as they had been in the past, they would fall along this dotted line. Each circle is a species, a bird species. So above that line are species that are now arriving later, below arriving earlier. You can see that the vast majority of migrating birds in the Great Lakes or Great Plains region are arriving earlier. That doesn't mean that they are keeping pace with climate change. It turns out that most of the long distance migrants and a lot of species that migrate a medium distance in the winter are arriving earlier, but not enough earlier. Spring has advanced because of the warming that this region has experienced. And really, it's only the birds in this blue box that are keeping pace with climate change. So we do see a response in the timing, but it's not enough of a shift. It's not just birds that are changing their timing, plants are as well. One of the things that has been recorded for decades and decades is the time when trees first put out their leaves in the spring. It's called spring bud burst. And in our region, that's happening 4 to 8 days earlier than it did in the middle of last century. Every orange or red dot is a place where records show that plants, especially woody plants, are putting out their leaves earlier in the spring. So throughout the Great Lakes region, that's been happening. For some reason, in the southeast of the US, the opposite has been happening. They're leafing out later. But in our region, clearly the spring bud burst is happening earlier. Another response that species can show is moving themselves around on the planet. And generally, of course, that means in the Great Lakes region, that means moving away from the equator and towards more northern latitudes. So northward range shifts. And it turns out that about a third of tree species east of the Mississippi have actually shifted their ranges significantly northward in the last 30 years. Every green arrow here, it's a little bit of a complicated graph, but every green arrow is a tree species that has moved significantly north in the last 30 years. But it doesn't mean that it hasn't moved in other directions as well. It just means that part of the move, part of the range shift involves a significant northward move. And what you can see right away is that most of the arrows are not green. And so most species are not shifting north, and tree species are not shifting north. And the ones that are, very few of them are shifting directly north. And a lot of them aren't shifting very much at all. A lot of the green arrows are small. It turns out that on average, species have been shifting northward faster than animal pollinated. Oaks are shifting north faster than, for instance, sugar maples. But even the ones that are shifting north are not shifting fast enough. And if 35% are shifting north, as they should to keep pace with a moving climate, that means 65% are not. So this is typically the case across all kinds of studies, that a minority of species is showing the response that is necessary to keep pace with climate. And the other thing is that for our trees, just like for most species on the planet, those that are responding in time or in space are not responding fast enough to keep pace with a moving climate. Okay, so climate's been changing. There's fair evidence that species are responding, animals and plants, but a minority are actually responding, and those that aren't responding enough, and for the most part. Okay, so now let's look into the future and ask, how will our climate change in the future? And we need to consider three different possible futures, with the idea that the magnitude of climate change this century depends on us. There are a number of possible futures available to you guys. I think of this as three alternate versions of the rest of your lives. The one that we are currently headed towards, the pathway we're on, is called the business as usual pathway. It gets atmospheric carbon dioxide to 950 parts per million and causes about 4.5 degree Celsius temperature rise, close to 9 degree Fahrenheit average global temperature increase. By the way, this graph down here, starting 400,000 years ago, running to today, is atmospheric CO2 during the last climate cycles on our planet. It never got above 300 until 1950. It's now, atmospheric CO2 is now about 415 parts per million. So if we consider the pathway we're on, which is this, business as usual, it is so far out of recent experience on Earth that it really is a very novel environment. Okay, if we and other countries meet our commitment that we agree to in the Paris Agreement to limit warming to about 2 degrees, then we need to keep carbon dioxide from exceeding 550 parts per million. If we do, we'll keep warming to about 2.2 degrees above what it was before the Industrial Revolution. If we do even better and follow an emissions pathway that I call Paris Extended, nobody else does. So if you use that term, nobody will know what you're talking about. But the Paris Agreement said, yeah, we're going to limit warming to about 2 degrees, and if at all possible, we're going to limit it to 1.5 degrees. To do that, we'd have to keep carbon dioxide levels from not exceeding, or at least returning to, 450 parts per million. We're almost there. So if we want to make this your future, we've got to get active very, very quickly. But if we do that, then we'll limit warming to 1.5 degrees. What I'm going to try to do is show what the future of the Great Lakes region would be like under business as usual, under Paris Agreement, and where possible, even under Paris Extended. Okay, so let's look at business as usual first. One of the measures of temperature that we would be interested in is a summer that is hotter than today's record hot summer. So what if you're in Kalamazoo, if you're in Battle Creek, if you're in Grand Rapids, if you're in Hastings, doesn't matter. Wherever you are, what's the chance that by 2070, if we keep on our current pathway, a summer will be hotter than what is today the record hot summer for where you live? And the answer is, under business as usual, in the Great Lakes region, it's over 90%. So in the Great Lakes region, it's almost all red, which means 90 to 100% of future summers will be hotter than today's record hot summer. Would the Paris Agreement change that future at all? Would the future be different under the Paris Agreement? Yes, it would be quite a bit different. Instead of 90% or more, it could be as little as 10% in the Great Lakes region. Okay. What do farmers do if the summers are routinely hotter than any they've ever grown crops under? What do public health departments do when heat waves are the norm rather than the exception? Okay, we can prevent a lot of that from happening by cutting emissions to meet the Paris Agreement. Overall, we're most interested, I think, in the summer temperatures. By 2100, under business as usual, the pathway we're on, summer temperatures in the Great Lakes region, which will sometimes be abbreviated GLR in these slides, would increase by about 6.5%. 6.5 degrees Celsius. The global average increase is about 4.5 degrees. So even though we've got all this water mediating temperature change, we still change more than the global average, quite a bit more. We warm up quite a bit more than the global average. BAU stands for business as usual. Here's the prediction for temperature change in our region by 2100 under business as usual. Let's consider summer precipitation as well. Unfortunately, along with this massive increase in summer temperature is a pretty sizable decrease in summer precipitation. Again, this is going to make the kind of agriculture we've been able to do in our region quite a bit more difficult. And I'll wait till the end for questions, if that's okay. Would the Paris Agreement change anything? Yeah, so it would cut the warming about in half, about 3.5 degrees summer warming, and would cut the decrease in precipitation about in half, only a 5% decrease. And that set of conditions, less warming and less decrease in precipitation, obviously is way more stressful, way less stressful. The Paris Agreement future is way less stressful for species, ecosystems, and people in our region. The most deadly extreme weather event is droughts. There are very, very few land-based species can survive extended droughts. So we also want to ask, what would the frequency and severity of droughts be like under these different futures? And it turns out with 3-degree warming, remember, business as usual gets us to 4.5 degrees. So this is quite a bit less than business as usual, but even with just 3 degrees warming, much of the Great Lakes region would experience 3 to 5 times more severe droughts than we have historically. Okay, if we look in our area, there's a lot of red. Red means 300 to 500% increase in drought severity, or droughts are 3 to 5 times more severe. Would the Paris Agreement, 2-degree warming, change things? Yes, there's actually very little red and quite a bit of blue. Under the Paris Agreement, we would be as likely to have a decrease in drought as an increase. So almost all of the increase that even 3 degrees warming would cause in drought severity would be prevented by Paris Agreement, and even more prevented by Paris Extended. Now, you might wonder, if there's warming under Paris Extended 1.5 degrees, why isn't there more drought? And the answer is there's more precipitation also. And the precipitation more than compensates for the increased temperature. If we look not at especially hot days or periods, but at especially hot summers or periods of heat without rain, and just ask about very hot days, days over 100 degrees. Under business, currently Kalamazoo basically has no days on average per year over 100 degrees. So currently we have 0. Under business as usual, by mid-century, we'd have 9 days a year. Later, 3/4 the way through the century, 14, and twice as many of that as that in the end of the century. So we basically have a month of days over 100 degrees Fahrenheit in Kalamazoo. If we implement the Paris Agreement, we cut that by about 1/3. So by end of the century, instead of 30, we'd have 20. And if we implement Paris Extended, we cut that about in half. We'd still have an increase, but it would be a much smaller increase than under business as usual and even under Paris Agreement. I was asked to give a talk to the Michigan Snow Sport Industry Association. They were much more interested in what's going to happen during winters than during summers, of course. And unfortunately, the story is that under business as usual, and I don't have predictions for other emission scenarios, Paris Extended, but under business as usual, most of our winter precipitation isn't going to be snow anymore. It's going to be rain. Okay. So here's the current percent of winter precipitation that occurs as snow. So all the way over on the right is all of it is snow. All the way over on the left is none of it is snow. But in Michigan, it's been 60 to 80%. But the prediction under business as usual is it'll be 10 to 30%. Most of our winter precipitation will be rain. And of course, that means that whatever snow does fall, even if it accumulates, it gets rained on pretty quickly and doesn't remain as snow. Okay, so if you like snowy winters, Paris Agreement and Paris Extended almost certainly would be way better than business as usual. Okay, so we have a lot of choices. This is quite a range of futures. All of them currently are possible. The better ones, Paris Extended, isn't going to be possible if we don't, 10 years from now, if we don't act quickly. So there's an urgency if we want that to be the future. Let's ask, under these various futures, how will species and ecosystems in the Great Lakes region be impacted? Aquatic ecosystems are probably the easiest ones in which to predict climate winners and climate losers. Aquatic ecosystems, by warming alone, will be quite dramatically affected. And it's a pretty easy prediction that if you like warm water, if you're a warm water species, you're likely to benefit, at least in the short run, from climate change. You're going to be a climate winner. But if you like cool or cold water, then you'll be a climate loser. And fish do align themselves in different temperature ranges quite predictably. Okay, so who is likely to be a climate winner? Carp, bluegill, catfish, perch, including, of course, Asian carp. Not the fish that most people like the best in, let's say, in the Great Lakes. Certainly not the fish that bring tourists and that form the basis of a fishing tourist industry. Climate losers, on the other hand, are exactly those fish. They're the deeper water, the cool and cold water fish, whitefish, all the trouts, walleye, all the salmons. So they will, the fish that we value the most in the Great Lakes are the ones that are most likely to disappear. One of the most threatening, I think, components of climate change that is not discussed very much yet, I think it really should be, is what climate change is going to do to what we call the summer stratification period. And as you can see from the wording at the top, it's that summer stratification period is predicted to increase dramatically. What is the summer stratification period? Okay, so the short explanation is that when the lakes warm up a little bit in the spring, oxygen gets mixed down from the surface into the deep waters. That mixing stops. And then whatever oxygen got mixed down in the spring has to last the deep water fish until the lake can mix again when the surface cools in the fall. So the surface is warming earlier in the spring, it's cooling later in the fall. The time between those two events is the time during which the lake gets stratified and oxygen cannot reach the deep waters. So whatever gets mixed down during the spring has to last until the fall. It has to last for the entire duration of what's called the summer stratification period. Okay, so what's predicted to happen to that amount of time? Remember now, this is an additional number of days that the spring oxygen, the oxygen that gets to the trout and the walleye and the salmon, that has to last. And the prediction is for Lake Superior, there's a predicted 3-month increase in how long that oxygen has to last under business as usual. I am not I'm not a limnologist or a fish physiological ecologist, but it seems very unlikely to me that the oxygen will last that long. And as a consequence, it seems very likely that we will have massive suffocation events of the kinds of fish that we value the most in the Great Lakes. For Lake Ontario, it's a 2.5-month increase. For Lakes Michigan, Huron, and Erie, it's about a 2-month increase. I think that is likely to be disastrous for the cool and cold water fish in our Great Lakes. Would the Paris Agreement make any difference? Yeah, it would cut the increase, not quite, but close to, in half. So Lake Superior, it would be 50 days, Lake Ontario also 50, but in 1 month instead of 2 months for Michigan, Huron, and Lake Erie. Again, I think that would prevent quite a bit of the mass die-offs from basically deep water fish suffocating. It's not just the Great Lakes that stratify. Inland lakes stratify as well. It's a picture of Douglas Lake, where I spend my summers, University of Michigan Biological Station. The summer stratification period for Douglas Lake under business as usual would be about a month longer. Under the Paris Agreement, it would increase but by 11 days less. And under Paris Extended, or 1.5 degree warming, it would increase by only 2 weeks. I think the Paris Extended, of course, would be much less likely to cause massive mortality of fish in inland lakes as well. Okay, so those are lake aquatic ecosystems. What about rivers and streams? I think the biggest danger for species that live in flowing water is days when there is not much flow, when the levels get low enough that there just isn't a lot of water to flow through that creek bed or river bed. And as a consequence, the water heats up, it gets low in oxygen, and so on. High flow days are also potentially dangerous because you can be displaced downstream by the force of the water. What is predicted to happen to high flow days in the Great Lakes region under business as usual? Not quite a doubling, almost all in the spring, but 86% increase under Paris Agreement, also a big increase, not quite as big, but a big one. But this is where I think the two futures really have different consequences for species in flowing water. And those are low flow days. Okay, in the summer, under business as usual, we expect about a 50% increase in low flow days, which I think are the biggest mortality days. Under Paris Agreement, there's basically no change. An increase of 3% or so, not statistically significant. And I think that's where the flowing aquatic ecosystem species benefit the most from Paris Agreement. One other consequence of warming is an increase in toxic algal blooms, both because the water is warmer and because if the severe precipitation events are occurring, they're washing more pollution into and fertilizer into the lakes. This is Lake Erie with a large toxic algal bloom that required Toledo to shut down its water supply, which was drawn from Lake Erie. So toxic algal blooms are toxic, like I say, it'll kill fish. Pets should not go in, humans should not go in the water when the algae are blooming. What's the prediction under business as usual? Green is a big increase in toxic algal blooms, and what we can see is by mid-century or late century, both inland, well, all kinds of inland aquatic ecosystems are predicted to see a big increase in toxic algal blooms. The algae or the cyanobacteria that cause those blooms have a competitive advantage in warmer water. Okay, under business as usual, we look at terrestrial ecosystems, land-based ecosystems. And Riley, you're keeping track of time, correct? Are you going to give me a warning when there's different numbers of minutes left?
Yep.
Okay.
What do you like?
I think 15.
15?
15 and 5, maybe.
Okay, I can do that.
Okay, thanks. So for Michigan, under business as usual, a lot of the trees that we think of as being part of Michigan forests are going to be in real trouble. They'll decline by at least 50%, including paper birch, both of our aspen species, balsam fir, each of which is predicted to basically disappear, almost disappear from Michigan. They remain, but only in small parts of the Upper Peninsula. And then things like white cedar and two species that I think of as the most iconic species of Michigan forests, Michigan trees anyway, and that is white pines and sugar maples. Okay, that's just my personal opinion that these trees are just part and parcel of Michigan, and they both decrease pretty dramatically. Would southern Michigan have sugar maple by the end of the century under business as usual? Almost certainly not. Okay, so those all disappear or decline dramatically under business as usual, but under the Paris Agreement, some of them don't decline. All of them don't decline as dramatically, and some of them don't decline by 50% anymore, including the two that I think of as the most iconic Michigan species. So we get to keep healthy populations of white pine and sugar maple. Forests are more than just trees. We also pay a lot of attention to birds. And for Michigan, under business as usual, we would lose or almost lose, so lose 80 to 100% of the populations of 24 other bird species, including loons, grosbeaks, and the others that you can see here. So under business as usual, basically your children and grandchildren probably will not have an opportunity to see those or hear those birds. Under the Paris Agreement, instead of 24 declining precipitously, it's only 10. And we get to keep, of the ones that were on the slide originally, we get to keep 5 of the 8. They no longer decrease very dramatically. I don't know if you can hear this. Can you hear that? Okay.
We can hear it.
So that's a sound that we can hear in our forests right now. Under business as usual, we won't, the students listening, you won't be able to hear that later in your life, and your children and grandchildren may never hear it. Thrushes to me have the most beautiful calls. Okay, so it's not just the species that were on that slide. Many other Michigan bird species would not suffer dramatic declines if we were to implement Paris Agreement. Okay. If we look at the zip code, if we look at this, one of the Kalamazoo zip codes, 49009, Audubon Society actually has very detailed predictions for over 400 species of birds in North America, going up into Canada, down into Mexico. And they'll let you, on their website, you can search by zip code and ask how many species would be highly vulnerable under 3-degree warming or 2-degree warming or 1.5 degree. Okay, this is Paris Extended, Paris Agreement, and about halfway between Paris Agreement and business as usual. But we can at least compare under these 3 different possible futures. Under 3-degree warming, 13 species in the Kalamazoo region would become highly vulnerable. They're on this slide. Under 2-degree warming, now it's only 5 species that are highly vulnerable. Under 1.5-degree warming, it's only 2 species. So even very locally, ecosystems would benefit substantially by implementing Paris and, if it's possible, Paris Extended. Okay, there is, if we back up and ask overall, could there be massive ecological changes? What we really are asking is, could one major ecosystem change into another? Major ecosystems, of which there are about 11 different types on our planet, are called biomes. And so what we want to ask is, what's the chance that biome will actually change into a different one? Let's talk about what we mean by biome change. So moderate biome change would be something like the boreal forest, the conifer forest north of us, getting replaced by the mixed hardwood conifer forest of Michigan. So our forests move up and take out part of the boreal forest. That would be a biome change wherever that, a moderate biome change wherever that occurred. But it's one forest type replacing another. A major biome change would be something like a tropical rainforest becoming a savanna, which is a prediction under business as usual for large parts of the Amazon rainforest. Okay, so let's ask, what would happen? Would biome change occur within the Great Lakes region? And how much of it would be prevented by the Paris Agreement? Here are the colors on the map that'll come up in a second that indicate major / moderate or moderate biome change. And basically what you can see is almost all of the land surface, except for deserts and ice sheets, almost all of the land surface is at risk of at least moderate biome change, including basically all of the Great Lakes region. If our biome changes, then would the Great Lakes region still feel like the Great Lakes region? I can't imagine that it would. Would Michigan feel like Michigan? I can't imagine that it would. It would just not feel like home. Paris Agreement eliminates almost all of that. Globally, biome change mostly happens at high northern latitudes or high altitudes. There is still some moderate biome change within our region, but almost all of it is prevented. That means to me, Great Lakes region still feels like the Great Lakes region. What about human health? As you would guess, I'm sure, human health is likely to be impacted by climate change. Remember that warming this century, and therefore any health impacts of heat events, depends on our choices about how much greenhouse gases we want to emit, how much we're willing to emit. And in fact, our choices over the next few decades matter the most for determining what the future is like throughout this century. Just to remind you, business as usual has this sort of heat signature associated with it by end of century, about a 4.5-degree rise. Paris Agreement, about 2.2, and Paris Extended, about 1.5. So we know that there are dramatically different amounts of temperature rise associated with different levels of emissions. And that's true for the Great Lakes region, just like it is true for elsewhere on the planet. Okay, extreme heat, it does affect human health. And if we have more of it, it's going to have adverse impacts. We don't actually want to talk just about temperature. The best indicator of how heat will affect human health requires that you combine heat with humidity into what's called the heat index. Heat index includes temperature and humidity. It's a better predictor of human health impacts because the way our bodies deal with heat to prevent ourselves from overheating inside our bodies is to get heat to leave our bodies by using it to evaporate water off of our skin. We sweat. Problem is, if it's highly humid, we can't evaporate water off of our skin as well. And so we can't move heat away from our body. If the heat index is above 100 degrees, children and elderly people, also pregnant women, anybody with underlying conditions, it's dangerous for you to be outside. If the heat index is above 105, it's dangerous for everybody to spend a lot of time outside.
Sorry
Even
to interrupt you, but there's 15-minute warning now.
great, thank you. And if we get, there is a phrase called heat index off the charts, which basically means this is a higher heat index than humans have lived in so far. So we really don't know what the effects would be, but it's very likely that it could be lethal to almost anyone who spent a lot of time outside during a day. Okay, let's just look at the difference between heat index and temperature. If we had a temperature of 100 degrees, very hot day, no question. But if we had along with that 60% humidity, so a hot and humid day, it feels like 129 degrees. That's the heat index. That's what it would feel like to us. So we can get into extremely stressful situations, heat indices, without having temperature actually be incredibly high. Aggressive emissions reductions, Paris Agreement, Paris Extended, would dramatically decrease the number of extreme heat index days in the Great Lakes region, in the Midwest. The days per year at various that would reach various levels of the heat index are indicated on the y-axis, the heat index itself on the x. So historically is in black. Historically, on average, the Great Lakes region, which includes areas far south of us, on average had 6 days a year with a heat index of 100 degrees. Under business as usual, by 2085, the prediction is that'll increase to 53 days per year. Paris Agreement would about cut that in half. Still be more than today, but only half as many as business as usual. But what about heat index days of 105? 3 historically, almost more than 12 times that by end of century under business as usual. And we prevent more than half of those by implementing Paris Agreement. No analog heat index days. They're called no analog because we haven't experienced it yet. So historically, the number is 0, but 7 days per year under business as usual and less than a third of that under Paris Agreement. Okay, so we'd have many fewer dangerously hot days. It is also important to think of, well, how many days in a row would we have? And especially in cities where populations are concentrated. And if we have 30 days per year, more than 30 days per year, it's quite likely that a number of them will occur consecutively and will have lethal heat waves. What I want to show here is all of the cities in the United States, late century, so think 2085, that would experience on average, in an average year, would experience at least 30 days with a heat index above 105 degrees. All of the big dots on the left side are cities, and including quite a few in the southern part of the Great Lakes region, like Grand Rapids, like Detroit. Okay, so if we think about the Great Lakes region, would Paris Agreement make a difference? Yeah, absolutely. There's only one city under Paris Agreement that would have at least 30 days, and it is a relatively small city in southern Missouri. Okay, that would prevent a number of heat waves. The prediction is that for Chicago, studies have been done for individual cities quite often. Well, not often, but most of the studies on heat waves have addressed individual cities. The Paris Agreement would prevent each year Um, by mid-century, each year about 450 deaths due to heat waves. And by the end of the century, every year it would prevent 3,700 deaths. So one of the ways to think about this is that's a benefit of enacting the Paris Agreement. Continuing along business as usual, conversely, another way to look at it is continuing to use fossil fuels like we do, we're saying we're willing to have this many people die per year in Chicago, because we don't want to shift. We don't want to have the inconvenience of shifting. Okay, I think that the value of the human life, if you work that into the sort of cost benefit equation, there's no question that we need to shift to Paris Agreement or Paris Extended. Anyway, if we get back closer to home for Grand Rapids, per decade, Paris Agreement would prevent about 6 heat waves, and very importantly, the ones that did occur would be shorter. Why is that important that they're shorter by 3 days? Human mortality increases exponentially as a heat wave continues. A heat wave of 8 days is way more than twice as deadly as a heat wave of 4 days. So if we can shorten the heat waves, that saves lots of lives as well. If we look at the probability of heat waves that are worse than the most severe heat wave known in human history, which was the 2010 Siberian heat wave, we can ask what's the probability that a heat wave that bad or worse would happen in a given year under business as usual in the Great Lakes region. It's actually pretty likely that in any given year we get a heat wave that's worse than the worst known heat wave in human history. But in Paris Agreement and Paris Extended, it basically doesn't happen. We don't have to worry about that. So again, huge consequences for human health. Um, by relying on fossil fuels, we are also poisoning the air. And if we're putting into the air very small particles, especially when we burn coal, very small particles, PM 2.5 particles smaller than 2.5 microns, that when breathed in, get everywhere in our body and mess up basically every organ system, especially respiratory and cardiovascular. Okay, so we're poisoning the air by burning coal and also to some extent by other fossil fuels. If we were to meet the Paris Agreement or Paris Extended, we would absolutely get rid of coal-fired power plants. We'd have to. And we'd replace coal-generated electricity with wind and solar, maybe geothermal, maybe others. Just in Michigan, that would prevent 1,100 heart attacks per year and 700 deaths per year. Why? Because coal kills. Every yellow dot here is a coal-fired power plant. The red, these are counties in different shades of red. The red indicates the mortality rate due to coal-fired power plants in that county. And of course, darker red is higher mortality. Michigan has quite a bit of coal-related mortality. 700 people a year die in Michigan because they're close to a coal-fired power plant. Okay, all of that disappears. It's a huge human health benefit. Okay, I'd like to show these two possible futures because they're still both possible. Business as usual, the one on the right, is the future that right now we're headed towards. The one on the left is Paris Extended. It's a much better future that's still possible, but if we don't act very quickly, it will not be possible a decade from now. Oops, sorry guys. Okay, years are going by in the bottom here, and what we're seeing is temperature change in degrees Celsius. So you could basically double it for Fahrenheit. By 2030s, we're already seeing a big difference in North America. Okay. 2070s, about the time you'd be retired and enjoying your old age. Okay, those are two of the futures we've been talking about. Um, this world is going to be an incredibly difficult one to live in. There will be so many challenges that we have no capacity yet to overcome. On the other hand, this world is a lot like today's, much more so. So, is this a world we should shoot for? In my opinion, absolutely. So, at this point, I would hope that you're asking, well, what can I do to help make the better future actually happen? The good news is we can make that better future happen by using solutions that we already have, with solutions that are already available. First thing everybody can do is, hey, while we're getting most of our energy from fossil fuels, let's use less of it. Okay, so we practice energy efficiency and energy conservation. Here are some of the things you can do. You can go to the dollar store and get weather stripping and prevent heat loss from your doors and windows. Even if you rent the house for $10, you can pretty seriously increase the energy efficiency of your home. And what does that do? It means that less carbon dioxide is put into the air because we have to burn less coal to make the energy that you're not using. Next time you get a car, get an electric car. Get one that gets at least 10 miles to the gallon better, but why not go for a car that gets way more miles per gallon and ideally doesn't use gas at all, uses electricity? Hey, if we shift to solar and wind generated electricity, then you can drive your car without increasing your carbon footprint at all. Eat lower on the food chain. Vegan has the lowest carbon footprint for a diet. Vegetarian's better. If you are going to be an omnivore, the one thing you would want to remove from your diet is beef. Even if you're going to substitute chicken for beef, you'll be lowering your dietary carbon footprint quite a bit, about 75% actually for the average carnivore. So yeah, think about ordering a chicken sandwich instead of a burger. In your house, wherever you live, turn the thermostat 1 degree a week in the direction you don't want to turn it. Turn it down in the winter, turn it up in the summer. All those mean we're going to put fewer greenhouse gases into the air by using energy from fossil fuels. But it doesn't change the outcome, it just delays it unless we start to get our energy from something other than fossil fuels. Using fossil fuels more slowly just makes all of those predictions happen a little bit later. What we have to do is not use fossil fuels. We have to demand that our policymakers enact policy that are just smarter, saner energy choices. I think our governor, our two senators are on board with this. I don't know yet about Peter Meyer. He's been very reasonable in a number of things he's done so far. So I hope that he will just act on the science again. And of course, the shift in the White House is very dramatically a shift in climate policy. So I think in November, your futures became a lot better just on the climate front. Okay, what do we want policymakers to do? Enact policy that will make us get at least 80% of our energy from smarter, saner sources, especially solar and wind, in my opinion, by 2040. Could we power the country or the world by these? Globally, we could produce 100 times all of the energy, not just electricity, all the energy humans use by any of three solar technologies. We could produce 40 times all the energy we use as a species by wind power. What do we need to do? Shift everything we can to being powered by electricity and then create massive amounts of carbon-free electricity. We absolutely can do it. One of the ways you can make your policymakers know your preferences is to put your boots on the ground. Okay, go next time there is a climate strike and there is a march or there is a gathering. Make sure your body is part of it. Bodies count. This is September 20th, a while ago, okay, 2 years ago. If you missed that one, say, okay, I promise I won't miss the next one. What will make policy happen is tens of thousands of young people marching, being public and saying, you have to stop stealing our future. Because quite honestly, that's what my generation is doing to you guys. And it's not fair. Okay, but you have to tell us to stop. Get other people to understand the science. Talk to them about the causes, consequences, and solutions for climate change. The easiest group to talk with, of course, is your friends. You can talk with people at work, talk with coworkers. Very important to talk with people who don't think the same way you do. More and more people are accepting climate change as a fact and supporting policy that lets us prevent some of it. Even self-identified conservative Republicans are more and more in favor of switching over to clean energy. So there may not be as much conflict as you think. So talk to people who think differently and absolutely talk to other young people.
All right, I gotta interrupt you. So we want to answer some questions. We only have like 5 minutes before this next session starts.
That's fine, Riley. I think I have 3 slides left.
Okay.
Let me just finish and then for sure. Plus,
All right.
if anybody wants to, they can contact me by email too, if we don't have time to get to the question. But just to continue where we were, really important to get the youth voice to be very loud. You can also do that by joining what I call Climate Truth Organization, the one for young people. Absolutely. I think it is the organization that's going to change the future. It's called the Sunrise Movement. It is the most active youth climate organization. Definitely consider joining or starting a regional or local hub of the Sunrise Movement. And if you can't yet, as soon as you are able to vote, make sure that climate change is a major voting issue. For me, it's by far the #1 issue in me choosing a candidate. The people who inhabit those 2 buildings, more than any other people on the planet, are controlling your future, are determining your future. Get people into those buildings who will stop stealing your future and start protecting it. So absolutely vote. And I think being a climate voter is a really good idea. Future depends on our choices. We have multiple futures available to us now. Your voice is going to matter a tremendous amount. You are in the unfortunate position of being handed a future that is not a fair future. It's not a good, it's not a fair future, but you're in the fortunate position of being able to actually change the future. And that means that unlike probably any generation in the history of humanity, you can be the generation that saves the world. And wouldn't that be a nice thing to think about having done when you look back at your life at the end of it? Okay, thanks for listening. I'll take questions. Anybody whose question doesn't get answered, feel free to email me. I can put Riley, do you want to put my email in the chat? Can I do that?
You can put your email in the chat.
Okay. So I'll stop sharing now.
Thank you so much for sharing that with us today.
Sure.
I really enjoyed it and really appreciate it.
My pleasure. Such an important issue. It's the least I can do. So do you want to, I'm just typing in my address, which is pretty easy. Do you want to choose the questions or filter the questions?
We only have 1 minute until the next session starts.
Okay.
So can we just tell them that they can email the questions?
Yeah, I'm the next session.
Yeah, unless they want to stay.
Pardon?
If they want to stay for the next session.
No, I was thinking we don't have to worry about transitioning. So.
Oh, okay.
And the next one starts at 11:35?
At 11:30.
Oh. Okay.
All right.
Riley, the next session does start at 11:35,
Oh, it does? Okay, sorry about that.
so there is time.
Well, if they're still here, we can answer the questions. Because we got 5 minutes.
Mhm.
I have no idea if they are.
Well, I see 20 participants. So whether, I mean, I guess the question, Riley, is I don't see any questions in the chat. So if you see,
I can read them to you. Sarah Young asks, under business as usual, why would the plains experience so much less warming than the Great Lakes area?
I'm not sure what she is referring to. Let me see if they basically don't. So, oops, sorry. Warming, for one thing, there is always a latitudinal gradient. In warming, it warms more at the poles, in part because the first response to warming, so this is, let me just share my screen here. If that's, I'm not sure which figure was it Sarah is referring to, but Sarah, yeah. So the farther north you go, the more frozen stuff there is. Frozen stuff is the first, melting is the first big change that happens with a little bit of warming. Frozen stuff, ice, snow, reflects a lot of sunlight back to space before it can be converted into heat. But if the snow or ice melts, then, and that includes the seasonal snow cover that we have in Michigan, then the water or land exposed underneath it absorbs most of the sunlight and converts it to heat. So a big reason I think for this change in color here, for more greater warming in the Great Lakes than at least farther south, is that we are losing reflective surfaces, and that's causing a positive temperature feedbacks, making us warm faster. Whereas farther south from us, there is no seasonal snow in a typical year. So they aren't getting that positive feedback, if I'm understanding your question correctly. So Riley, if you don't mind, I actually would like to take a 1 or 2 minute break, just rest my voice before starting at 11:35. Is that okay?
Yeah, go ahead.
Okay, I'll be back. Yeah, I'll be back